All right, so join with computer audio first. There we go. All right, so this is where we left last time. I do want you to add colors to the parts, and the way you need to do it in the part file, which you can open from either home or just the regular open. And you can actually open them from the assembly. If you're looking at the assembly, you can right click on the part file on the part you want to open up and open it from there, and then you can make your changes. If my inventor ever comes back, that is not a good sign for when we try to do animations, but maybe it'll work. There we go. And there we go. All right. So yeah, so the way you open up a part from here is make sure you are highlighting just that part, or even mousing over, and then you right click and go to open, and it will open that part file. Okay, you can see down here at the bottom where it says wheel.ipt. IPT is the inventor part. IAM is inventor assembly. And here, the way you change it is you change the one called default, and you go all the way through. Until we get good at animation, please don't use any of the like clear ones. It just makes it really hard to explain where to click. Where are the clear ones? There's some sort of glass. Is it under G? Glossy. I don't know. Maybe they got rid of the clear ones. Oh yeah, clear blue, that sort of thing. It makes it really hard to explain. All right, when you constrain, you click on this thing and not that thing. So solid colors for now. When you get to your own things later on, maybe. All right. That's kind of ugly. Okay, I'll keep it regular for now. All right, so our goal here is we are actually going to bring in the straight track, and actually a few of them, and do an animation where the wheels actually spin. And I will pick up from exactly where you are. Okay, so you get here and we have a completed assembly. The train body is grounded. You can see the little push pin there. I know it's super small, but you should be able to spin the wheels around. And every once in a while, it'll do like a weird, like it jams up the linkage arm, but that's fine. When we do our next thing, we're going to lock things in place and it'll be fine. As long as it goes around, like if you grab the linkage arm when it's flat, does it go all the way around without jamming? If it comes to one spot and it doesn't move, and then it pops over to the other side, there's something wrong and it's going to be an issue. And the most likely issue is the distance between the axle holes. If the distance between this hole and this hole is not the exact length of the linkage arm, it's not going to spin consistently. Okay, so, or spin correctly. So we do need to, we're going to bring in one of the straight tracks, constrain it underneath, and then we are going to bring in more straight tracks to make like, I don't know, 3 feet or 4 feet, if this is, 6 inches, 3 or 4 pieces of straight track in a straight line. And we're going to make the train go down the tracks and spin the wheels as it goes down the track. Okay, so the first thing we're going to do is place. Here is an issue that a lot of people have trouble with. Okay, so when you want to edit your train assembly, you need to open that train assembly, either from home or from the regular open. If you start a new assembly it will let you place the old assembly. You can place an assembly in another assembly, but it won't work if you do that. Okay, so you need to be looking at your assembly file, and you should be able to see all the parts on the side there. And it's still loading. This is going to be a struggle. I might need to do it on a different computer. Okay. I wonder why it's such a struggle. I wonder if your PCs are better. Okay, so in a second, when this all comes back, we're going to click on place, and we're going to place just to start one of the straight tracks. This is getting old. There we go. Okay. So we'll go place, and we're going to choose straight track or train track or whatever you called it. No, I don't want that. I want one of the regular pieces, and it'll come in on its side, but that's fine. And we can just place one, click one to place it, and right click OK. All right. So you can free orbit individual parts, free rotate, I mean, and you can move things around the way you would on a regular thing, but it doesn't matter because when we constrain it, it will pop to the correct direction. Okay, and let's do a couple to start. First thing, let's flush the back. Like line up the two parts, like this back face with this back face. So at least it'll be pointing the correct direction. So we'll do constrain, leave it on mate, switch it to flush. Again, you could see in the little pictograph there that the two faces with the arrows pointing out are in line. And here they're together. We want the one where they're in line. And we're going to first click there and second click there. Love that sound. And then hit OK. And let's look at it straight on. All right. So we've got it lined up. It can only move in this direction. And if we turned it, it would be able to move this direction, but it won't move off the back of the train. Okay. So next thing, let's get it so that it's at least flat to the side. And for this, we're going to do an offset constraint, but it's going to be very similar. Let's constrain, also switch it to flush, and we're going to flush the side of the train to the side of the track. And if we look at it, before we click OK, you could see it's not lined up correctly. We want the wheels to be directly over the notches, which we could do a little math and figure out how far it is from the side to the start of the notch, and then add half of the amount of the wheel, like the thickness, but we can also just sort of walk it in. Okay, we're going to change the offset here before we hit OK, and let's see what one does. Okay, it at least goes to the correct direction. If it went the wrong direction, we would need to switch it to negative, and it just has to do with which one you click on first. It doesn't matter. Just if it goes the wrong direction, negative's the answer. But it's not lined up, so we need to change it, and we're just gonna, it's not really eyeballing, I mean it is, but it's also sort of walking it in until it's right. So 1 inch was too much. Let's see what 0.5 does. 0.5 is not enough. What does 0.6 do? Still not enough. 0.7. I think that looks pretty good. So the offset is going to be 0.7. And so now we've got it lined up here, and we've got it directly over the tracks. And if you're ever not sure which constraint you still need, grab the part that still moves and figure out which way it moves. It only moves up and down, so we need to constrain it to that height. Okay, and we could do the same thing where, of course, when you want to do a constraint, you need to get the part out of the way. So the way that we just did to reinforce it would be to do, in this case, a mate constraint, because we want to mate the undercarriage of the train to this top surface there. And then before we click OK, start figuring out, okay, it's 1. Okay, it's at least positive. 0.5, too much. How about 0.4? That's pretty good. 0.3, 0.3 is not enough. 0.35. I kind of like 0.4. Okay, that's one way to do it. The other way is this option called predict offset, where you put the part exactly where you want it. And when you go to do the mate, before you click on the parts, you set the, it is called show preview. Oh yeah, predict offset and orientation. You could do it the way I just showed you, but this way is a nice trick. If I want it to be exactly this offset, whatever it is, I can do this predict offset and orientation. And when I click on the bottom or the top of the train track and the bottom of the train, it will tell me that offset. You saw it pop to, I'll do it again so you can see it pop. The issue with that is that setting stays on, and you rarely want the setting. So being aware of that is good. Okay, so where are we right now? We have this. We have our offset. We're going to mate the top of the train track to the bottom of the train body, and it will pop and then fill in with the correct offset. Okay, so there is our first piece of train track. And at this point, the train is grounded, but the track is fully constrained. We want the track to be grounded and the train to be movable, because we're going to move, we're going to change the constraints, but we want the train to be the thing moving, not the train track. So make sure you have everything deselected, okay? Because if you have this selected, but then right click on the track, you're going to be you're still affecting the train body. So click off to deselect everything. And then on the train track, right click and find grounded. And that will put the push pin thumbtack into that part file there, which you can also get to any of the parts through the browser bar over here. Okay. And once we do that, we are going to unground the train body, which you can do from here. Right click, uncheck grounded. Also, you can right click, uncheck grounded. I suppose doing it from the browser bar is probably better, just because you're never going to click on the wrong thing. Where, like I said, if you have this highlighted and you right click on this, you're still working with the train track. So we want the train body to be ungrounded and the train track to be grounded. Okay. Now, when you click on the drop down for any of the parts, you can see all the constraints that are related to that. You know, it's called the relationships. So here on track, we have that first flush we made, the 0.7 offset from the side, and the 0.4 offset from the bottom. And if we wanted the train to move, we could just delete this constraint and it would move, but we don't really need that yet. What we need is a couple things first. Okay, so the goal is to have the train move down the track straight, but we also want the wheels to spin. So the first thing we're going to do is we're going to constrain the wheels to each other so that they spin together and at the same rate. And the way we're going to do that is we're going to do an angle constraint with its origin planes, and we need to turn on the visibility of the wheel's origin plane. So we're going to open up that part file, which at this point, the easiest way is to right click and do open, which I already have open. Please don't crash it. Okay, in the wheel part file, you need to go over to origin, and there are 3 origin planes everywhere. There are 3 origin planes. One of them will be sort of flat. Yes. One of them will be sort of flat against the large face of the wheel, and the other 2 will slice across. On either of the ones that slice across, you're going to right click and turn on visibility. Okay. And when you do that, when you go back to the assembly file, it will be visible. Okay, obviously at the end, we're going to turn that off because it looks gross, but it is needed for this first thing. Okay, so here, it will literally break or literally fail to do a constraint if your linkage or the distances aren't right. But what we're going to do is we are going to do an angle constraint between these two so that when one spins, the other will spin. And in order to make these all work, we're going to constrain, we have to constrain the front wheel of each to the back wheel of each side, but then constrain across so that they all go at the same time. Okay, so first, right now, we just have the train body constrained, and we just turned on the visibility of the origin plane. I think it ends up looking better if it's this one, the one that goes through the nub, but it doesn't matter as long as it's one of the ones that slices across. And then in the assembly, we're going to go constrain, and we're going to use the second one, angle constraint. And I don't know why the first option is this reference vector thing. The one I've only ever used is directed angle. So we switch it to angle constraint, and then we switch it to the first one. And then just on this right side, we're going to click, first click is going to be this, the origin plane of this wheel, and you got to get over sort of the edge to get it. That's the first click. And the second click is the origin plane of this wheel. And as long as it pops, you're good. And now when you move one, it will move, which it kind of did before, but before it would jam occasionally. That's not the critical one, you'll see, but we're going to do the same on the other side. Angle constraint, first type, and constrain this origin plane to this origin plane, wherever you can find it, and hit OK. And now these will always spin together without jamming. But now, in order to make this work, we need to constrain the origin plane of this one to the origin plane of this one the same way, so that when you spin one side, it spins both sides. So we're going to constrain, angle constraint, and do the exact same thing from the back left to the back right. And it doesn't have to be back left to back right, but it's just one on each side. Did I mess up? Oh, it's got to be the first type. I'll start over. Constrain, angle constraint, first type. And we're going to angle constrain this origin plane to this origin plane. Oh, and I have the offset thing set on. You'll be probably at 0, and that's fine. It kind of looks cool if we change it later. I'll show you when to do that, though. Okay, so I hit OK. And now I have, when I spin one, it will spin the other. When I spin one side, that is, it will spin the other because they are lined up. And actually, I didn't mean it to be, well, you see, if I turn off the visibility on this, you can see that one of the sides is up while the other is down, and that's fine. I think that looks good. I actually think a 90-degree offset is fine. But if yours comes out where they're both up at the same time, both down at the same time, that's fine. I'm talking about where the linkage arm is on each one. Okay, so we've got angle constraints, and they spin at the same time. Now we need to get it so that it, when the train moves forward, the wheels spin. First thing I'm going to do is go back to the wheel part file, which is still open, and turn off the visibility of the origin plane there. And it never hurts to save. If something says update, agree with it. I can't recall a time that I didn't want to agree to updating. And I would say, when in doubt, save the main assembly from time to time. Hopefully that doesn't break it. Yeah, yes to all and hit OK usually would be the issue. I didn't like how that was read. I'm not really sure what that meant, but we're gonna try our best. All right, so in order to make this work, first thing we have to do is get rid of the constraint that's holding the back of the train to the back of the track, which that constraint, if you click on the drop down, excuse me, for the track, there will be 3 constraints there, the 3 that we just did. And this first one, called flush 3, is the one that's on the back. But this constraint is between the train body and the track. So flush 3 will also be available under train body, although remember all the ones we did for the train body for all the different parts, but flush 3 is right there. It's the same constraint. Either place, you need to delete it. And so we'll do right click, delete. I'm going to do it from the track options, just there's fewer there. And now when I grab it, the train body should move. Good. The train wheels still move, but we want to make it so that when the train moves, the wheels also move. Okay. And so we're going to do a constraint, and we're going to do a motion constraint. This is pretty rare. We don't usually do this. In fact, I think this is one of the only times I have. Motion constraint. And the second type is rotation translation, which just means when the train goes forward, something rotates or they compare to each other. Okay. And the first click needs to be on one of the wheels so that it gives you that center axis of the wheel. And just clicking on, you know, like where the tire would be, will give you, that's your first click. And your second click is on one of the edges of the track that goes lengthwise, not the face, the edge. Okay, so get an edge, and you'll see that arrow points out. It doesn't matter which one you do, whether you could see this one edge right here has the arrow pointing left, and this one has the arrow pointing right. It doesn't matter. Depending on what you click, the value will be negative if it goes the wrong way, but that's fine. Okay, and our offset, our distance, is 1 inch, which means when the train moves 1 inch forward, the wheels make 1 full rotation. We're going to have to change that. You'll see in a second, but I'm going to leave it at 1 inch, and that's okay. Okay, so now when I move the train, the wheels move. But the wheels move too much because they do a full rotation. Like I said, when the train moves 1 inch forward, the wheels go all the way around. We want the wheels to go once around every time the train moves the circumference of the wheels. I don't know if that blew anybody's mind, but the train moves linear in the forward direction, the same distance as the wheel's circumference every time the wheel does a full rotation, which is kind of redundant and kind of insightful at the same time. So in that constraint, which is underneath the track, it's called rotation translation, and rotation translation 1. We are going to right click and edit it. And so instead of having each wheel rotate every time the train moves 1 inch, we want it to move, rotate every time the train moves its circumference. And how big is the train wheel? Okay, well, let's open up the wheel. And I'll close this. That's from the last one. The wheel, let's see here. Let's look at a sketch. Okay, so the wheel is, its radius is 1.125. So that means its diameter is 2.5, which means its circumference is 2.5 times, we'll just use 3.14 because it's close enough. Okay, so you can just stick with me on this one if you're not getting the basic geometry. Thanks. Right here, we'll right click on that, edit, and instead of every inch, we want it to do a full rotation every time it goes 2.5 inches times 3.14. That's close enough. And hit OK. And now the train will do a full rotation, or the wheels will do a full rotation when the train moves forward. And I think you'll agree that looks a lot more realistic than what it did a second ago. Okay, you should be able to grab and move the train body, and the wheels should rotate, and they should rotate both sides. Okay, so all we did, that rotation constraint or that motion constraint is only on this wheel, but because that wheel is tied to the other ones, all those other things happen at the same time. Okay, and we did something pretty major, so let's go ahead and save it. And why is this? Okay, multiple files, updated the current session. Do you want to change? And its dependence. Yes, you all. Okay. And please don't break. Please don't. Okay. So we want to bring in a few more pieces of train track so that we can show the train going down all the tracks. All right. And I think maybe 3 more pieces for a total of 4 is probably enough. So let's go ahead and place. And it might be the most recent. Yep. Train track. And we'll hit open. And I want 3 of them. So I'm just going to go 1, 2, 3. Right click. OK. And so we need to line these up. You might think the best way to do this is to do an axis constraint with this axis constraint. And it would kind of work, except even when, let's go ahead and I'll do this and show you that it's not correct. Even if you line them up, when you line them up like this, they don't touch, I don't think. Wait, do they touch? Are they exactly centered? I actually think they might touch. All right, but we're not going to do it that way because I already decided and used a tone that doesn't make sense. All right, so what we're basically doing here, starting from scratch or starting from just these, no constraints on our new track, is anytime you're constraining 2 things that are mostly flat, if you're only using mates and flushes, you're always going to have 3, like 3 flushes or 2 mates and a flush or something like that, because you need to constrain the 3 dimensions. Okay, so first thing I'm going to do is constrain. I want to flush the tops because I know those need to be the same level. Apply. And if you just hit apply, it doesn't close, keeps the same settings. I know I want to flush the side to the side. Hit OK. And again, if you're not sure what the third one is, grab it and see if where it moves. And here I want to flush, excuse me, mate, like glue together this face and the face that it's going to touch. So we'll constrain, leave it on mate, and mate this face to this face. Hit OK. Okay, and you should be able to grab the second one and not have it move. I'm going to do the same thing twice more. Constrain, flush this to this. Apply, flush this to this. Hit OK. And I could have kept going, but I can't see the faces I want to constrain. So I got to move it out of the way. We'll leave this last one on mate. And I want to mate this face to this face. Hit OK. And then the last one, same thing. Constrain, mate, excuse me, flush this surface to this surface. And also flush this surface to this surface. Hit OK. And it's in there somewhere. That was probably bad. If something like completely gets consumed by something, you can right click, turn off visibility from here, and then put it back on if that happens. I don't recall that happening before, but there you go. All right, so I've got the 2 constraints. I flush the tops and I flush the sides. I just need to mate the parts that are glued together. Leave it on mate, click there, and click there, and hit OK. And I'll save it again here. I don't really know if this is likely to crash or lose the things, but when in doubt. Okay, so now when you grab the train, you should be able to move it all the way down and all the way back, and it should rotate realistically. So the way we're going to animate it is one of at least 3 different ways you can animate things. It's a real basic one, which is why we're doing it first. what we're going to do is we're going to flush the back of the train to here, from here to here. And then once it's there, we're going to do an animation called drive constraint, which makes, over the course of a certain amount of time, makes that constraint offset increase. So that it's moving, thank you, I got you, moving the train body. Okay, so we're going to do a constrain, and we are going to flush this face. Does that one not work? Okay, we're going to flush. I'll start over. Constrain, flush this face to this face. Hit OK. And now when you grab the train body, it shouldn't move. The train, nothing should move actually, because they're all locked in place. And that constraint is going to be either under train body, and it's going to be the last one under train body because we just did it. It's also going to be under track 1 because that's the one we connected to. It's called Flush 11. And if you're ever not sure, there is this relationships tab or folder that has every constraint in the entire assembly. But we're really only interested in the last one under train body. That's probably the easiest way to find it. And we're going to right click and do drive, which is a coincidence that it's a vehicle, but we're going to drive. And let's just see what happens when we hit go now. Okay, it went 10 inches, which is not very far. If each of these is a foot, well, we're starting here. If we want it to end there, it's 1 foot to there, 2 to there, 3 to there, and then a little bit. So maybe 40 inches. And we play, and it goes down the track. Excellent. All right. So we are going to record this. You're going to make a video, and hopefully the computers can handle it. And then you're going to submit it as a file. You can look at it from a corner. You should probably try to fill the screen, and we'll probably have to mess with the settings to get a good quality recording and angle and that sort of thing. But I think it's probably a little cooler if you record it sort of coming down the track or going down the track, but no points on or off for that. I'm going to put it like this. Okay, so we've got the recording or the animation set up. We'll go back to the beginning, and let's see what happens when we hit record. It will probably ask us for a file name. How about mini train drive animation, something like that. Make sure you know where you're saving it. Probably make sure it's just going into documents, which is where you're saving everything, and hit save. And then we want custom profile. These settings are probably fine. 640. We'll worry about custom ones later, but the best of the standards are fine. We hit OK, and then we do have to hit play and hit OK. And let me see if it worked. I don't know if it pops up automatically. Okay, well, it popped over to my documents folder, which if you're not sure how to get to that, if you don't have this folder right here, or I think everyone has this folder down here. Yeah. Open up a regular folder, and it should be the most recent item on there. And if I double click on it, it should play, and we'll see what the quality looks like. I've lost it. There we go. Okay, so it's not super awesome quality-wise. You can also see that it's recording sort of there. Let's see if we can get a better quality one. Let's go back. Let's find that constraint. And you see I left it at full distance. I'm going to edit this back to 0 because it's going to be weird if it comes in that way. So let's edit this and set it back to 0. You could also delete it and run it the other way. So I know it's picking up sort of the middle of the area. And I'm not too worried about the resolution, but I think I can improve the quality. Okay, we're still here with flush 11. We're going to drive. I like from 0 to 40. Let's see what a second of pause does. And let's hit record. And we'll save it as, I'm going to have it replace the same thing. Yes, I want to replace it. And what is this? I think this might top out at 1500. Let's see what that does. Hit OK and play. And I think it's slower because it's recording a higher quality. But again, this is a bad sign for our future advanced animations. I don't know how I'm going to do it. Maybe I'll bring in my own computer. Or I'll just do it on desktop. Maybe I should be doing that anyway. Doop-a-doop-a-doop. I wonder if somebody with the exact same settings is able to get a better, or at least a faster rendering. And we're done. We hit OK. And let's see what it looks like for realsies. Not super awesome. I forget how to get it better, but that's fine. If that's what yours ends up looking like, that is fine. Actually, can you all do me a favor? When you go to save it, can you put your names in the file name? So I'll do it again from scratch. Okay, so we flushed the back of the train, and if you want, you can set it up like this, but you do know that it needs to be centered. And let's go ahead and we'll do right click on that, drive constraint. I'm fine with this. We'll do record. And in the file name, you know, your name, mini train animation. And I spell it right, I can't tell, it's too small. And I don't know how to get bigger than this. Let's see if a larger constraint or a larger resolution works. But either way, let's hit OK. A width between 176 and 1200. Is that 1200? I mean the width. And we hit play. And it chugs along, so to speak. That was a pun. Nobody laughed. It will finish eventually. When did we start? Has this really been 45 minutes? Okay. And for this assignment, you are going to submit your recording to the appropriate assignment on Canvas. And like I said, pretty please put your name in the file. And let's see what this looks like. Go to documents and refresh it. And we hit run. It's going to be bigger, but is it still going to be poor quality? No, that's a little better. There you go. All right, so that is how you do the basic animation for train, and we'll figure it out. All right, good luck.